practicing this stuff, it's not like I can clearly see, okay, where techniques are being used. It takes time. It'll take time. We'll get there. Hi friends, welcome back to the channel. I'm not going to mention the fact that we had to put our dog down yesterday because I'm really sad about it and I don't want to think about it. If you're new here, my name's Ash. I'm 27. I'm a cybersecurity enthusiast, and on this channel we play Capture the Flags, we go through tryhackme walkthroughs, and we learn together on our journey to success. On today's video, we're going over day 18, Sigma, of the Advent of Cyber 2022 challenge from tryhackme. For all details, see the description for playlists, timestamps, links, and all that sort of good stuff. All right, let's get started. Okay, so over on tryhackme now, we've got a virtual machine, so I'm gonna start that up. We've got day 18, which is task 23, Sigma. I have no idea what Sigma is. I don't know if it's a tool, I don't know. So I'm going in completely blind. So we have a blue text, meaning it's gonna be blue teaming, so defense. And we've got here that our infrastructure has been compromised. And the SOC team is wondering if their actual methodologies to perform threat detection could have been faster to analyze logs. So, okay, I'm starting to get a little idea of what we're doing. So first section is threat detection. So as we've seen through the previous days, cyber threats and criminals use a lot of different ways to gain access and steal information. So it's the same for the blue team, the people who are defending. There's proactive steps or approaches that the blue team can take to analyze different logs, malware, and network traffic. So this is the practice of threat detection. So it involves proactively pursuing, analyzing abnormal activity within an ecosystem to identify malicious signs of compromise or intrusion in a network. Next section, attack scenario. So we've been handed the logs and information concerning the previous attack. So through various analyzing, it was clear that the logs pointed towards an attack chain called the unified kill chain. In that chain, there was persistence, discovery, and execution. So first, they persisted by creating a local user account that they could then use during the attack. Then the attackers sought by gathering information about their target, by running commands to learn about the processes and the software on the devices, and they searched for potential vulnerabilities. Then the attackers scheduled jobs to provide initial means of executing said malicious code, which then provides them a way of persisting and being a part of elevating their privileges. So we have a attack chain report, which includes our indicators of compromise, or IOCs, and the necessary detection parameters, and they've been linked to the MITRE attack framework for reading. I don't know about you, but even from day one with frameworks, I do find it a little difficult to sort of compartmentalize the different attack techniques in my head. Like as we're going through, I think it just is going to come down to practice. Like as we're doing the rooms and as we're actually, practicing this stuff, it's not like I can clearly see, okay, where techniques are being used. It takes time. It'll take time. We'll get there. So we have account creation, software discovery, scheduled tasks, and we have the event IDs, the service, the event ID category for software discovery. We've got the process creation, event ID, service, sysmon, so we can see the image that was used and the command line. So required detection fields, category, the ID, the image, command line, strings. So the same for the scheduled task, which was process creation, and it's running calculate. The calculator was created. That's just a test. Okay, so before we proceed, we need to deploy the attached machine. So let's go ahead and do that and jump into our VM. Okay, we're on the VPN, and we'll just open up our system in Firefox. Okay, so we're on our IP for the remote system. We've got Advent of Cyber Sigma hunting, your Sigma rule.yaml. Is that YAML? So this is going to be the config file and attack chain details. Got challenge 1, suspicious account creation, challenge 2, software discovery, challenge 3, scheduled task creation. Okay, I have no idea what's going on. This is exciting. So going back to our instructions, we've got our Sigma application. So this is Sigma that we're looking at, and it has the following features. We can submit your Sigma rule and see if it detects the malicious indicators of compromise. Oh, okay, this is a text editor. We can write our Sigma rules in this section. We can create rules. We can create a Sigma rule for the malicious indicators of compromise. So I guess when you write this, you are dark, that is then the rules. And then view log. View the log details associated with the malicious indicators of compromise. So I guess this is then those logs. Okay, I'm not going to hit run just yet because I don't know what is going on. Let's do the next section, chopping logs with Sigma rules. Just understood the lumberjack reference at the beginning. So Sigma is an open source generic signature language developed by Florina Roth and Thomas Patsky. I'm so sorry if I'm getting your names wrong. To describe log events in structured format. The format involves using a markup language called YAML. I've used YAML a couple of times. A design syntax that allows for quick sharing of detection methods by security analysts. The common factors to note about YAML files include the following. YAML is case sensitive. So we can see all of our fields here are all lowercase. Files should have the YAML extension .yml. Spaces are used for indentation, not tabs. That's a big one. I think I was trying to do Docker a while ago and I was using tabs. Yeah, so learnt that one the hard way. Comments are attributed using the hash character or pound symbol. So we can see here, we've got all these commands. So we might be using these to help us. Key value pairs are denoted using the colon character. Okay, so if we have a title and then we call like this is the title, so this is a key value pair, this is the value, and this is the key. Array elements are denoted using the dash character. So down here we can see tags dash. So this is how we can have multiple values for one key. I think. Not an expert here. I'm just going off my limited programming experience and what I understand. Don't quote me. So Sigma makes it easy to perform content matching based on collected logs to raise threat alerts for analysts to investigate. So log files are usually collected and stored in a database or a security information event management, SIEM. Is there a way to actually pronounce that? SIEM? How do we say that? Solution for further analysis. Sigma is vendor agnostic, therefore the rules can be converted to a format that fits the target SIEM. Sigma was developed to satisfy the following scenarios. I just remembered that that's an Overwatch character. To make detection methods and signatures shareable alongside indicators of compromise and YARA rules, SIEM searches that avoid vendor lock-in, to share signatures with threat intelligence communities, and to write custom detection rules for malicious behavior based on specific conditions. Right, so that's cool. So you can write these rules, you can share them with anybody else, you can use them on any software, and you can automate your findings and create your own custom detection rules. As somebody who's like using this for the first time, Sigma makes a lot of sense why it exists. So next up, we've got Sigma rule syntax. So Sigma rules are guided by a given order of required/optional fields and values that create the structure of mapping queries. The attached image provides a skeletal view of a Sigma rule. So we have a quick look. It's similar to what we've got in here. Title, status, description, author, reference. We've got some more included in our actual Sigma instance over here. So let's use the first attack step challenge to define the syntax requirements, fill in the details into our skeletal rule, and detect the creation of local accounts. Use the text editor section of the SIG hunt, it's over here, application to follow. Names the rule based on what is supposed to be detected. So we're looking for suspicious account creation, so we'll give that the title. ID, a globally unique identifier that the developers of Sigma mainly use to maintain the order of identification for the rules submitted to the public repository, found in UUID format. What's UUID format? A sequence of digits equal to 128 bits. Cool. Thank you, online UUID generator. Status describes the stage in which the rule maturity is at while in use. There are 5 declared statuses that we can use: stable, test, experimental, depreciated, unsupported. So stable, the rule may be used in production environments and dashboards. Test, the trials are being done. The rule could require fine tuning. Experimental, the rule is very generic and is being tested. It could lead to false results, be noisy, and identify exciting events. Depreciated, the rule has been replaced and would no longer yield accurate results. Unsupported, the rule is not suitable in its current state. So I guess I'm just going to go for a test. I'm not really sure. Okay, I can see down the bottom here that there's a few differences. I'm just going to copy exactly what they've said. We've got local. They have an ID. Do I have to use their ID? Sure, I'll use your ID. I'll be a sheep. You've used experimental. Fine, mine isn't good enough. Oh, I used the capital T. I just realized that's... Well, they use the capital T there, but not there. Maybe in the value, it doesn't really matter. And then we have a description, provides more context about the rule. Yeah, we know what a description is. So I'm just going to use those. Detects the creation of a local user account on a computer. That makes sense. So we have a log source. Describe the log to be used for the detection. It consists of other optional attributes: product, category, service, or definition. So a product selects all log outputs of a certain product. So examples are like Windows, Apache. Okay, so it grabs everything that Windows is spitting out. A category selects the log files written by the selected product. So example, a firewall, web, antivirus. So more of like the application, but I mean, Apache could be, okay. A service selects only a subset of the logs, examples SSHD on Linux or security on Windows. Okay, definition describes the log source and its applied configurations. So in this case, we are going to be using the product of Windows and the service security. Next up, we've got the detection. A required field in the detection rule describes the parameters of the malicious activity we need an alert for. The parameters are divided into two main parts. The search identifiers are the fields and values the detection should search for. The condition expression sets the action to be taken on the detection, such as selection or filtering. The critical thing to look out for account creation on Windows is the event ID associated with user accounts. In this case, event ID 4720 was provided for us on the IOC list, which will be in our search identifier. Okay, so sort of getting it. We're now writing the conditions of things that we actually want to look for. We've just specified exactly where we're looking for, like what log we're looking in, and now we're trying to filter down. So this is done under the detection, selection, and then here we've got change me. I think we can get rid of these curly braces. So we've got field 1, event ID, and this is going to be an array. So we can go enter spaces 1, 2, 3, 4. I think it's 4. Maybe it's 2. There's 2. I'm just going to go with 2. 1, 2. And then here we can do the dash for an array 4720. I'm just going to copy the commands in because I'm not going to do anything. But and then we have condition selection. So action to be taken can use conditional operators such as and or not when using multiple search identifiers. Oh, okay. So it's like a little bit of like programming you can put in here. That's kind of crazy. So the search identifiers can be enhanced using different modifiers appended to the field name with the pipe character. The main type of modifiers are known as transformation modifiers and comprise the values contains, ends with, starts with, and all. Some of these modifiers will be vital in writing rules against other IOCs. Right, so do we add these underneath the event ID? Is that? No, this is just an example. We've got random_rule.yaml, so we're not supposed to actually use this. But we can see here we've got image, so an image that ends with svhost.exe, a command line that contains all bash.exe, and then a -c flag, condition selection. Cool. I'm getting about 20% of this, if I'm being honest. So some other things, some more information to make things clear. False positives, a list of known false positives that may occur based on log data. Okay. Level describes the severity with which the security team should take the activity under the written rule. So we can see here, if we were typing in an array 1, 2 dash unknown, and then level, we'll just type out low, so just informational, and then tags adds information that can be used to categorize a rule. Common tags are associated with tactics and techniques from the MITRE ATT&CK framework. Sigma developers have defined a list of predefined tags. Right, so so the tactic is persistence, and then the attack technique is this. Cool, so the Sigma is just a whole world in itself. Voila, we have written our first Sigma rule and can run it on the Advent of Cyber Sigma hunting application to see if we get a match. As mentioned before, Sigma rules are converted to fit the desired SIEM query, and in our case, it should be known that they are being transformed into elastic queries on the back end. Various resources performed this task, with the native tool being Sigmac, which is being depreciated and replaced with a more stable Python library, PySigma. Another notable tool to check out is uncoder.io, an open source web Sigma converter for numerous CIEMs and EDR platforms. It's easy to use and allows you to copy your Sigma rules on the platform to select your preferred backend application of translation. Okay, so there's like Elastic Query, like what we're using, Splunk. I've heard of Splunk. Okay, there's a whole lot of other tools. Next section, activity. So equipped with the knowledge about Sigma rules, your task is to complete the remaining 2 challenges by writing rules. Oh, are we supposed to run this? Okay, well, successfully detected suspicious login account creation. Here is your flag. Oh, I thank you for telling me exactly what to do to get my first flag. So that was for what is the challenge number 1 flag. We'll just finish this off then, go on to the tasks. So we're being relied on to beef up the security for the adversaries attempting to stop Christmas this year. As a reminder, the required fields for the attacks are below. So we are going to have to change these things for software discovery and for the skewer jobs. Now, I believe we will then be using this information in our, like this was the report we were handed. And then we're going to be changing the rules based on our report, I think. Okay, so we've done what is the challenge number 1 flag. Next, we've got from the challenge 1 log, what user account was created. So let's go view log. Oh, this is nice. And we can look at, we've got all of, yes, things. So this was the suspicious account creation, and the subject username is administrator. No, it's not. Target username is Bandit Yeti. Okay, so that's done with this first one. So we have our next, what is the challenge number 2 flag? Okay, so we have 4 rules that we need to focus on: the category, the event ID, the image, and the command line. So let's go ahead and change things like our title, generate a new ID, because a good thing to do. We'll leave status as experimental. We'll change the description to detects the discovery of software created. That's terrible. Detects the software created. Okay, that's fine. I'm overthinking things. So we have our event ID in this case is number 1. The service that we are focused on is Sysmon. So we can see that here in our service. That's one of our options. Plus that's in our report. And this is still on a Windows system. This is all on the one Windows system, right? So we don't need to change the product, just the service and the event ID. And we also have the command line to change. But before we do that, we have our image. So if we go back to our example down here, we did have an image and a command line. So this can be done under the selection. So let's go ahead and copy this over, and we might need to make some changes. So I'm going to change our value of the image ends with to match our \regexe. Next, for our command line, we've got command line contains all. Like, I think we could keep that, and maybe instead of, running bash, we could just have running reg, and maybe, I'm not really sure how much of that to include. I'm just going to give this a whirl, see what we get. So we have changed, we haven't touched our category. So our category is process creation. So let's paste that in there with an underscore. So we've done our category, we've changed our event ID, we've changed our image and our command line, and even our service. Okay, so I'm confident in most things except for the command line, so we'll see what we get. So rule 2 generic, specify the filter. Filter required is security. I thought we were following this, but I'll listen. Oh, I'm editing the challenge 1. I just realized I'm just going to go Control A, Control S. I'm then going to go create rule for this guy, and then I'm just going to paste that in. I backspaced, I Control Z on the sysmon. Now I'm going to run. So need the YAML file for the right thing. Sigma rule 2 specific. Okay, so we don't want this whole thing. We just want H key, and now we run. Again, too specific. Maybe if we just comment that out, specify the filter, required filter -v. Okay, is that what we want? Wrong detection, hit count 2 of 1. Well, now I'm just confused. So maybe if we use the full image without the ends with, maybe that was picking up more things, just as an idea. We're still getting false positive, I think. So maybe we need to be a bit more specific with reg query. No hits found. Okay, cool, got it. I just switched out the command line contains all, and I use SVC version, so that was the last part. Honestly, not exactly sure what I'm doing. It's more just testing and playing around with, but hey, we got it. So we'll put in that one, and just out of curiosity, could we just comment that out and run that again? I know what I'm doing. So next up, what was the user's path in the challenge 2 log file? So let's go over to view, and we're looking for the user's path or the current directory in this case, and we can see we've got a user here, bandit -1 app data local temp 2, so we can paste that in, and that's not right. So let's keep looking. There's the parent image. Okay, maybe this is it. It was under the user tag here. Awesome. So what is the challenge number 3 flag? All right, this time let's go create rule. Sort of liked copy and pasting and having my other okay, so this time we have scheduled jobs. So we'll make that our title. We'll refresh and get a new UUID. So we'll have the status as experimental. We'll have the description as finds malicious scheduled jobs. Skip author, skip date, skip modified, log source, our product. So let's scroll back up. So I assume we're still looking at the same system. So it's still a Windows, plus we can confirm that by what's going on here. The service is sysmon, and we can just copy paste that from our helpful comments. Thank you for that, lowercase. So then we've got our category, which in this case, again, is process creation. Then under, we have our event ID again, same event ID, 2 spaces, dash space. Then we have the image that's being used, give that a copy. And if we go down to our example, we can have image, and we can paste that in there. There is a parent image, so I'm not sure if we need to include that. We'll start with the image, and we can have that as a, then for the command line, we can use the command line key and continue using an array. I'm just going to keep this down here as a comment just so we can refer back to it. So we might do a couple here. So we'll go contains all, and maybe we just have whatever contains scheduling tasks, and maybe just cmd.exe. Yeah, so whatever's then running this to then calculate. So that I guess that this is the issue. Maybe we could do the log on. We'll just leave it like that for now. So our condition is selection. We'll just give it a low level. I'm not really sure if this really matters for our test purposes, but I'm just going to leave tags. It's not like this is going public. All right, let's give this a go. We'll go run. So rule 2 generic, specify the filter required. Okay, so I didn't exe. All right, let's try that. Again, our rule is 2 generic, so we should be using create. So I'm going to replace it cmd with this dash create. No hits found. So that's pretty interesting. Perhaps the image is the issue this time. Maybe we could use this ends with and remove it like our example. Let's try that. Okay, still nothing. Maybe the parent image is what we're actually looking for then. Maybe. Still nothing. Okay, I'm gonna leave the image and I'm just gonna play around with this. I was just reading it wrong the entire time. The image, I had the wrong image. I do that so many times in these proofs, just really basic. Okay, so that was flag 3. All right, we got it. Let's go view log. What was the MD5 hash associated with challenge 3 logs? So we can see hashes and we've got MD5 equals this hash here. So we can paste that in, and we we completed it. We got there in the end. Alright, thank you so much for watching up until now. I appreciate you getting through all this of me stumbling. I hope that you've learnt something from this. Otherwise, you've just enjoyed watching me fail. Feel free to leave a like, a subscribe, and a comment, and ding the bell if you want to. Up on the screen, you're going to see a recommended video to one of the other videos on my channel and the playlist to all the other videos in this series. Thanks again, and I will see you in the next one. I've got more days to go and catch up on, so bye.